My name is Tabang and I'm currently a computer science student at the University of Johannesburg. This is my project. My project is about developing an analytics tool to automatically detect intrusions on a computer network based on network traffic. Computer networking dates back to 1961 when the idea of ARPANET was first introduced. Since then, computer networks have grown both in complexity and size as organizations increase their reliance on computer networking. This has then resulted in the safeguarding of digital assets becoming a crucial aspect of most organizations. However, the main challenge with this scenario is that there is currently a shortage of information security professionals across the world who are able to effectively analyze network packets to protect these assets. Also, where these professionals are available, they come at a huge cost to these organizations, making it almost impossible for most small and medium enterprises to be able to afford to have these professionals on their payroll full time. An organization with a tool which automatically detects network intrusions based on network traffic would not need to have a lot of information security professionals on their payroll full time, as most of their work would be partially automated. This would in turn reduce the skill set required to detect intrusions within a network, also reduce the amount of time taken to detect these intrusions, and as a consequence, reduce the cost of detecting these intrusions within a network. Internal auditors would also be able to monitor compliance against organizations' policies, as data would always be readily available. My project proposes a packet analysis tool to detect the following intrusions: port scanning, denial of service attacks, and the use of insecure protocols within a network. Each time a machine needs to communicate with another machine through a TCP connection, before it can actually start sending information, it would actually initiate a three-way handshake. In this three-way handshake, a SYN request would be sent to a target machine. The machine would respond back to the client with a SYN-ACK request if it's available. The client would communicate with an ACK request to acknowledge that it did actually receive the synchronization request from the target machine. And then both devices can start sharing information. This diagram depicts how an attacker would carry out a TCP SYN scan on a network or against a target host. An attacker would send a SYN request to a target machine, and if the machine is available, it would actually respond with a SYN-ACK request back to the attacker. The attacker would then be aware if whether the machine is available or not, and instead of actually completing the three-way handshake, the attacker would not send anything back to the machine, would actually leave the connection half open. To be able to detect unauthorized network scans, the application models the behavior of network packets which are sent through a network to perform port scans. It achieves this by making use of a combination of a binomial model and a threshold random walk algorithm, which looks at the SYN flags sent through a network, ACK flags sent through a network, and the packet lengths of these packets that are sent through a network. It also looks at the ratio of connection requests to positive responses. A high number of negative responses would indicate a possible port scan, as the attacker would not initially know which ports are open and which ones are closed. A denial of service attack and a distributed denial of service attack are both carried out in a similar fashion, whereby an attacker would send a SYN request to a victim host, the victim host would allocate resources to the connection and respond with an egg SYN request, and the attacker would not respond back and would keep on sending this number of this requests in a similar fashion until the host is unable to respond anymore and it becomes unavailable to legitimate users. Detecting denial of service attacks and distributed denial of service attacks works in a similar fashion, in that in this instance as well, a binomial model with a threshold random walk algorithm are used that looks at the SYN flags sent through a network as well as the SYN egg flags that are sent through a network. The packet lengths are also inspected, whereby shorter packet lengths may be indicative of a denial of service attacks, and a high ratio of SYN to egg packets could be indicative of connections which are left half open. The insecure protocol detection algorithm inspects each of the packets as they pass through the network, specifically focusing on the protocol aspect of the packet, comparing it against a signature database on the application of insecure protocols. If a packet passes through the network using an insecure protocol, it is flagged and reported back to the user. Datasets used to test this solution were obtained from the NetSec AB website, Maysbold knowledge base, and the Canadian Institute for Cybersecurity website. I will now do a demo of the proposed solution. When a user first runs the application, they would be prompted to log in. A user can log in as a super user, whereby they will get super user privileges such as being able to edit or remove insecure protocols, or as a normal network administrator, where they will just be able to run a packet file through this application to detect network intrusions. I'll run this application as a network administrator for this demo. Once I've logged in, I am now able to select a packet file that I would like to analyze. And once the packet file has been selected, a user would then be presented with an import button to be able to import these packets into the application. Once the packets have been imported into the application, the user would then be able to select the types of intrusions that they would like to detect from the captured network packets. And once this has been selected, a user can then click on detect to detect these intrusions. Once the application is run, a summary of results would be presented to the user, which would show for each of the attack types that had been selected, which ones have been detected. So here we are able to see that a vertical scan was not detected, a horizontal scan was not detected. However, a block scan was detected from the packet file, and the user is now able to download the results if they want to view the details. For denial of service attack, we can see that there was no denial of service attack that has been detected, including a distributed denial of service attack. When we move on to insecure protocols, we are able to see that 103 insecure protocols have been detected on the captured network packets, and the user is therefore able to download the details to download a file to view the detailed results.